friends, my name is Aitya Reddy YS. I am currently studying in Sri Venkateshwara College of Engineering from the branch CSCAI, section Infinity, subject Introduction to Python Programming. Today we are going to learn about topic called as Type-Based Dispatch. Introduction to Type-Based Dispatch. Type-based dispatch is a programming paradigm that selects the methods based on the type of the arguments. This mechanism contrasts with a traditional method dispatch, which may rely on the method's name or the order of definitions. Understanding type-based dispatch can enhance code flexibility and maintainability. History of dispatch mechanisms. Dispatch mechanisms have evolved from simple function calls to more complex models like a type-based dispatch. Early languages primarily utilized static dispatch, leading to less dynamic and flexible code. The introduction of object-oriented programming significantly influenced the development of a type-based dispatch. Key concepts in type-based dispatch. The type-based dispatch relies on the type of the arguments to determine which method to execute. The system inspects the types at runtime, allowing for more dynamic behavior in code execution. This approach can lead to improved performance in certain scenarios by optimizing method selection. Advantages of a type-based dispatch. One major advantage is increased flexibility in a method selection based on runtime types. It can lead to cleaner code and better separation of concerns in a large applications. Type-based dispatch can improve code reusability by allowing the same function to operate on different types. Disadvantage of a type-based dispatch. Type-based dispatch can introduce overhead due to the need for a type checking at runtime. It may lead to less predictable performance compared to static dispatch methods. Developers may face challenges in debugging complex type hierarchies. Comparison with other dispatch mechanisms. Unlike dynamic dispatch, which focuses on the object's runtime, type-based dispatch considers argument types. The static dispatch resolves methods calls at the complement time, while type-based dispatch does so at runtime. The choices between these mechanisms often depends on the specific requirements of the application. Type hierarchies and dispatch. The type hierarchies play a crucial role in how type-based dispatch operates. Subtypes can override methods from a subclasses, influencing methods resolution. Understanding these hierarchies is essential for implementing efficient type-based dispatch. Language support for type-based dispatch. Many modern programming languages such as Julia and Python support type-based dispatch. Each language implements it differently, affecting performance and ease of use. Developers should familiarize themselves with their chosen language's dispatch mechanisms. Methods resolution order, that means MRO. MRO defines the order in which methods are searched for in a type hierarchy. Type-based dispatch often relies on a MRO to determine which method to invoke. Understanding MRO is essential for predicting the behavior of a dispatched methods. Use case of type-based dispatch. The type-based dispatch is commonly used in frameworks and libraries to provide extensibility. It is also relevant in data processing applications where different data types require different handling. Developers can implement plugins that leverage type-based dispatch to extend functionality. Performance considerations. Performance can be affected by the overhead of a type checks during runtime. Optimizations such as a catching method lookups can magnate performance costs. It is essential to profile applications to understand the impact of a type-based dispatch on performance. Best practices for implementation. Clear documentation of type hierarchies and methods functionality is crucial. We consistently naming the convenience to enhance the readability of dispatched methods. Regularly review and refactor type hierarchies to avoid complexity. Type-based dispatch in a functional programming. The type-based dispatch can also be found in a functional programming such as a Scala. It allows functions to behave differently based on the type of their arguments. The approach can enhance expansiveness and clarity in functional code. Role of reflection in a type-based dispatch. Reflection allows programs to inspect and manipulate types at runtime. The type-based dispatch often utilizes the reflection to determine method availability, while powerful reflection can introduce security and performance concerns. Type-based dispatch in object-oriented design. In object-oriented design, the type-based dispatch enables polymorphism. It allows different objects to be created as instances of the same type, enhancing code reuse. Proper use of a type-based dispatch can lead to the cleaning and more maintainable design. Future trends in dispatch mechanisms. Advantages in a compiler technology may lead to the more optimized type-based dispatch implementations. The rise of a machine learning and AI may influence the evolution of a dispatch mechanisms. Developers may see new languages that better integrate type-based dispatch with perform optimization. Case study: type-based dispatch in Julia. Julia utilizes multiple dispatch, a form of a type-based dispatch, to enhance performance and flexibility. It allows functions to be defined by the type of all their arguments rather than just the first. This approach significantly enhances code clarity and performance in scientific computing. Conclusion: the type-based dispatch is a powerful mechanism for method selection based on argument types. It offers flexibility and reusability, making it suitable for various programming paradigms. Understanding type-based dispatch is essential for modern software development. Okay, thank you.